So guys, welcome once again. Before we've been looking at naming of monoatomic anions, now we are going to look at naming of monatomic cations. Now, naming monatomic cations is very easy. Since here we're going to say that naming. We just begin and say that they are named by writing the name of the element followed by the valence, in correct Roman numerals, and in parasynthesis and in parathesis. For example, if I have lead 2 ions, I write lead 2 ions. And please, there is no spacing here. No spacing. So that is how we name these monoatomic cations. I'm going to put a table that will have a variety of them, the ones that we are most likely to encounter. So we should be knowing how to address them. As chemists, we should be knowing how to address these things, simply because, we are saying that whatever rule is there is agreed on by the union that makes decisions for chemists. So we as you people as young chemists, you should grow up knowing the rules and how they apply, so that you do not blunder at any one time. So let us proceed by, we again look at them. I'm going to have my table here. Here I will have monoatomic cations. This side I will have the name. I'm very sure this table is not enough to accommodate all of them, simply because they are many. Let me try to be economical by drawing a reduced table so that we can have 2 columns. So here I'm going to have monoatomic cation. Then here we shall have the name of the cation. So I told you that hydrogen appears everywhere. So these are called hydrogen ions, as simple as that. Now another thing that you should know, if a cation is monovalent, if a cation has 1 valence, then that cation is you just write the name and you ignore the valence. For example, we can look at sodium. So this one shall just say sodium ions. because we know sodium exhibits one valency. We look at guys like silver. So these are silver ions. Don't waste time by saying silver one. If we go to aluminium's valency 3, but we know that aluminium exhibits only one valency, so this becomes aluminium ions. We look at an example like zinc. Zinc, this one we shall call it zinc ions. We shall call it zinc ions. We shall not include the valence simply because it is also monovalent. We look at magnesium. Since the cation, we shall just say these are magnesium ions. We look at another cation, calcium. Calcium is monovalent, so these are calcium ions. We look at another one, barium. Barium is monovalent, so we shall just write barium ions. I told you that our table will not accommodate all of them. We shall need to draw a second table. Shall we draw a second table where we shall again have the same labels. This is monoatomic cation. We have, and then here we stopped on barium. If we stopped on barium, we are going to add another element. Now the element we are adding here, I'm choosing, let us add an element that has more oxidation states. So this one is manganese 2 ions. This one becomes what? Manganese 2 ions. And I said that there is no spacing between the parentheses. You just write it as one word. If we look at another element that is divalent, this is tin. So this is tin 2 ions. If we have the same, then this is S4. This means this is tin 4 ions. These are our rules that we follow here, or we are going to follow. If we can look at the other thing that I had given in the example, we know that lead is diatomic, therefore this one we shall call it lead 2 ions. The other second valence of lead is lead 4. So this one we are going to call it lead 4 ions. The other element we are going to look at is the iron. We know iron is diatomic, so this is the iron 2 ions. Then we also have iron 3 ions. You also have iron 3 ions. Then from iron 3 we can look at guys like chromium, which have various oxidation states. So this is chromium 3 ions. So guys, allow me to clean the first table. We add more cations, such that after finalizing with these ions, we can go and look at the polyatomic ions. After this, we shall go and then look at the polyatomic ions. Here I'm adding cobalt. So cobalt has two oxidation states, that is cobalt 1 and cobalt 2, but the most common state is cobalt 2. So this is cobalt 2 ions. Then nickel. And now here you're realizing that we are dealing with the transitional elements. So if I'm dealing with the transitional elements, it means that they exhibit more than one oxidation state. That is one of the characteristics, as you will find out in your inorganic chemistry, that is group elements. So nickel also exhibits various oxidation states. Then we look at copper. Copper also exhibits various oxidation states, like this one could be copper 1 if it was 1. If I added 2, then it becomes copper 2 ions. Let me conclude with maybe copper 1 ion. So guys, these are the simple basic rules of naming inorganic cations, anions, and salts. As you will find out in organic chemistry, when you're studying organic chemistry, you will also find out the IPAC rules of naming organic compounds. So let us meet in the next video when you're looking at naming of polyatomic ions and compounds. Have a nice time.